Interpolation and extrapolation. Interpolation and extrapolation, these are the two techniques. We have two variables, one is x arguments and other is y entry. Some arguments are given to us x naught, x1, xn. These are the n plus 1 arguments which are given to us, and these are the entries y naught, y1, yn. One argument xk is given to us, and corresponding entry for this is missing. Yk is missing. Yk is missing. So estimating this yk can be done by interpolation or by extrapolation. If xk lies in between x naught and xn, then this is the problem of interpolation. If xk is more than yn, xn, or xk is smaller than x naught, then this is the problem of extrapolation. If the missing entry is within the given arguments, then interpolation. If it is here or it is here, then this is extrapolation. Interpolation and extrapolation can be divided into three segments. One of them is called equal spaced argument interpolation. Equal spaced arguments. Unequal spaced argument. Equal spaced argument means x1 minus x naught, x2 minus x1, and xn minus xn minus 1. They all are equal and the gap is h. While if they are unequal, means what? x1 minus x naught is not equal to x2 minus x1 is not equal to, and so on, is not equal to h, then we call it as unequal space argument. For equal space argument, we need simple difference table. Simple difference table. For unequal arguments, we need divided difference table. Divided difference table and simple difference table. How these tables are constructed, I am going you to demonstrate a simple difference table here. Simple difference table. How we can construct a simple difference table? Suppose these are the different values of x which are given. This is 1, 6, 11, and 16. These are the different values of x. And these are the different values of y or fx. Suppose it is 5, it is 9, 27, and 32. Suppose these are the arguments and these are the entries which are given to us. Argument values are 1, 6, 11, and 16, which are equal distances. 6 minus 1 is equal to 5. 11 minus 6 is also 5. 16 minus 11 is also 5. So we can see that these arguments are equally spaced. But we have not to check whether the entries are equally spaced or not. There may be a chance that the entries will be equally spaced, but this is not necessary. But the argument should be checked whether it is equally spaced or unequally spaced. If the arguments are equally spaced, we construct a simple difference table. So here we are constructing a simple difference table. If it is unequally spaced, then we have to construct a divided difference table. So how these difference table are constructed? The first column will be represented by delta. This is the first order difference. How you can calculate this difference? Quite simple. This is represented by delta y naught, the first entry here. This is equal to 9 minus 5. It is equal to 4. This is known as delta y1 because this is the first entry in the difference column. Can be calculated by 27 minus 9. How much it is? It will be 18. This is in the middle of 32 and 27. This will be delta y2. It is equal to 32 minus 27. This is equal to how much? 5. This is called first order simple difference. Now second order simple differences can be calculated by delta square. And this delta square can be computed by the difference of these two and will be put it in between these two. 18 minus 4 is 14. This is represented by delta square y naught. It is 5 minus 18. It is 13 minus 13. This is represented by delta square y1. The next column will be what? Is the delta cube. And delta cube can be constructed by the difference of these two. And it will be put it in between these two. So this is equal to delta square, not delta square, it is delta cube y naught. This is equal to minus 13 minus 14. It is equal to 27. And there is only one entry in the third column. What about the delta 4? Will not exist because if we have 4 arguments given to us, Then the third order simple differences will be constant because we have only one value here. And the fourth order and more than fourth order will be 0. So this is very one important conclusion about the simple differences. If we have 4 arguments, then the third order column will have only a single value. And after that, we have nothing. After that, we have 0. Delta 4 is 0, delta 5 is 0, and so on. If we have n plus 1 arguments here, then nth argument will be constant and n plus 1 order will be 0. So this is the conclusion of simple differences. Okay, Hasnan has corrected this. The correction is what? The correction is this is not 27. This is equal to 27 minus 27. This is minus 27. Now, so all of you have idea about the differences, how these differences are represented by the simple difference table are constructed. Simple difference table is constructed if the arguments are equally spaced, and divided difference table is constructed when the arguments are unequally spaced. On the next slide, I am going to demonstrate how the divided difference table is to be constructed. So I'm showing you on a single slide how the divided difference table are to be constructed.
Excuse me, sir.
इसमें डाल दें चैट बॉक्स में ताकि ये अटेंडेंस आपकी सेव हो जाए. सेक्शन के साथ डालिएगा ताकि ये सेक्शन वाइज में इसको बाइफरकेट कर सकूं. एक गूगल फॉर्म बनाया है मैंने. वो गूगल फॉर्म मैंने दोनों CRs को सेंड कर दिया है. उसमें आप लोग अपना डिटेल्स सेंड कर दें. मैं इसके लिए LMS की चूँकि बना हुआ नहीं है आपकी क्लास का, LMS बनाऊंगा और उस पर फिर क्विज अपलोड करूंगा और असाइनमेंट्स अपलोड करूंगा. तो ये अभी तक LMS नहीं था, तो इस वजह से कुछ असाइनमेंट्स और क्विजेज नहीं हो सके थे. लेकिन ये LMS जैसी बना देता हूँ तो क्विज कंडक्ट करूंगा आपके. ठीक है. अच्छा, सिंपल डिफरेंसेस की एक्सप्लेनेशन दे रहा हूँ. मैं रिकॉर्डिंग ऑन कर रहा हूँ. अभी क्वेश्चन आंसर अपने पास नोट कर लीजिएगा. फिर मैं रिकॉर्डिंग ऑफ करूँगा तो आप क्वेश्चन आंसर्स को रेज कर सकते हैं. अदरवाइज बीच में अगर आपको कोई क्वेश्चन आता है आप रेज हैंड कर सकते हैं. मैं वहीं पॉज करके आपके सवाल का जवाब दे दूंगा फिर. ठीक है. नाउ कम टू द how these deltas are calculated. Delta y naught is computed by y1 minus y naught, and delta y1 is computed by y2 minus y1. In simple, I can say that delta y naught is described as y1 minus y naught. And we can also represent this by fx1 minus fx naught, because y and fx are same. Y is equal to fx. All of you are familiar with the y is equal to fx. So we can represent the data with the help of y, or we can represent the data with the help of fx. Now in simple, how can I write down delta y5? Okay. If someone is interested to calculate delta square y3, suppose, so I can expand this by delta into delta y3. All of you agree, because this delta into delta becomes delta square. Now I expand this delta y3 by delta, and this delta y3 can be represented by y4 minus y3, or we can write down as fx4 minus fx3. This can further be subdivided as delta y4 minus delta y3. Now delta y4 can be represented by y5 minus y4 minus, with bracket we have here. Now delta y2 can be represented by y3 minus y2. So we can simplify this by y5 minus y4 minus y3 plus y2. y4 minus y5 minus y4, and I think there is an error. This should be y4 minus y3. This should be y4 minus y3, because delta, we have delta y3. y3 means what? y4 minus y3. So now we have y4 here, we have y4 here, so this will become minus 2y4. And we have plus y3, and there is no y2 in this expression. So this is the expansion of delta square y3. So we can represent any delta with the help of this type of representation. We can expand. This is the example 1, this is example 2, this is example 3. These are the 3 different examples of simple differences. I'm just going to complete the simple differences explanation here, and want to extend this making difference table for divided differences. So in the next slide, I am going to construct a divided difference. Divided difference. When divided differences are computed, x0, x1, x2, and x3. I am just taking only 4 arguments, because it will be difficult for us to construct this table for n arguments. And we have fx naught or y naught. We can use both notation, fx naught. This is fx1. This is fx2. This is fx3. One assumption is x1 minus x naught is not equal to x2 minus x1 is not equal to x3 minus x2, because arguments are unequally spaced whenever we are going to construct the divided differences. The first DD, we use the term first DD, first order divided difference. First order divided, instead of using the term delta, we use the term DD, divided differences. The first divided differences can be computed by f x naught x1. This is the divided difference computed in between x1 and x naught. This is representation. This is notation used for the first order divided difference. How this will be calculated? fx1 minus fx naught divided by x1 minus x naught. So there is one simple difference among these two. The difference is what? these two are to be subtracted in numerator, and in denominator these two be subtracted. This was absent in the simple differences. In the simple differences, that only the numerator. So the simple difference and divided difference, it has only one difference. That difference is what here we have a denominator, while in simple differences we have only numerator. Now this is computed in between these two. This is represented by fx1 x2. This is equal to fx2 minus fx1 divided by x2 minus x1. And the next is computed as fx1, fx2, fx3. This is equal to fx3 minus fx2 divided by x3 minus x2. Next column. Next column will be comprised on in between these two. This is represented by f x naught, x1, x2. So we have added one argument here because this is computed by x2 and x naught. This is computed for these three. How? How this is computed? This is computed as fx naught x1, this answer, and this answer, minus fx1 x2 divided by x2 minus x naught, x2 minus x naught. I am writing this first and this later. So I am just correcting some things here. This is not x naught x1. This is not x1 x2. This is to be write down as x1 x2. This is represented by x naught x1. If you are writing x2 minus x naught in denominator, then this minus this should be in numerator. If I am writing x naught minus x2 in denominator, then this minus this will be in numerator. Now the next column will be f x1, x2, and x3 is equal to what? F x2, x3 minus f x1, x2 divided by x3 minus x1. This is called second ED. The title of column is second order divided difference. I am writing the third order divided difference here. Third order because I cannot construct a new column here on the right side. That column that has only one entry in between these two. I'm just putting a star here. In the next column, I have this entry, f x naught, x1, x2, x3. This is equal to f x1, x2, x3 minus f x naught, x1, x2 divided by x3 minus x naught. So this is the construction of divided differences. Now you can ask questions.
सर फोर्थ ऑर्डर नहीं होगा सर कांस्टेंट किस तरह हो रहा है सेकंड ऑर्डर
आ जाइए. X is given to us and fx are also given to us. These values of x are 5, 6, 9, 13. So you can observe here, I'm increasing one more values because last time I took 4 values. Now I am taking 5 values, 1, 2, 3, 4, 5 values. It means the fourth order divided differences will be constant and the fifth order divided differences will be 0. Now values of y are also given to us. This is 9, 23, 42, 49, 57. So these values are given to us. What is the problem? Make a DD table. DD stands for divided difference table. So I'm just calculating divided differences, first order divided differences. Numerical values are what? Numerical values are 23 minus 9 divided by 5. This is represented by f x naught x1. Now here I am the second value f x1 x2. This is equal to 42 minus 23 divided by 9 minus 6. Here we have the next value fx2 x3. How this is computed? 49 minus 42 divided by 13 minus 9. And the last value in this column is fx3 x4. And this is computed by 57 minus 49 divided by 20 minus 13. These are the values of the first column or the first DD. You have to calculate all of these values. Then I will ask you what are the answers. There is an error in the denominator of the first value. This is 6 minus 5. This is 1. So I have to write down 6 minus 5 here. This will be 1. So can you calculate this again? Now in the next column, I will write down the direct answers. I will not represent the entire notation and entire calculation, but all of you should be familiar how these calculations are to be done. And this is second order divided difference. This is computed here. How this is computed here? 6.33 minus 14 divided by 9 minus 5. So I'm just writing it here. 6.33 minus 14 divided by 9 minus 5. This is the answer to be calculated here. And you have to compute it, and I will ask you what the answer. Okay. This is minus 0.061. Now in the third order divided differences, we have only two values. This can be computed by minus 0.6542 plus, because we have a double minus here, plus 1.9175 divided by 13 minus 5, because this is to be computed in between 13 and 5. So here we have answer. So I am just writing this expression. What will be the answer by just erasing these numbers, and you will have to get the answer. And all of these things are erased. And the new calculation will be, how the new calculation will be minus 0.65 4 to minus 1.9175 divided by 13 minus 5. What is the answer? You have to tell me the answer. In this table will be here. Third order divided differences. Now this entry can be computed by 0.0 by erasing these things first, because these are the previous calculations. The new calculation will be 0.0423 minus 0.1579 divided by 20 minus 5. How much is it? This answer will be minus 0.00706. This is the last value in this difference table. And now I'm concluding this table and explaining the few things here, how the divided difference table are interpreted and explained. Now, this is the difference table, and in this difference table, the third entry will be represented by f x naught, x1, x2, x3, x naught, x1, x2, x3, and x4. This is the notation for this entry. And this entry has a notation of f x1, x2, x3, x4. And this entry has a notation of f x2, x3, x4. This entry has a notation of x3 and x4. You can see it here. I already write down the notation here, fx3, x4. So if we have 5 arguments in the bracket, 1, 2, 3, 4, 5 arguments in the bracket, so we have third order divided difference. If we have 1, 2, 4 elements here, so we have, I'm sorry, it is third order. This is fourth order. This is fourth order. So I am just repeating my statement again. If we have 5 elements here, so it is fourth order. If we have 4 elements here, it is third order. If we have 3 elements here, second order. If we have 2 elements here, so it is first order. And what is this? This is fx naught only. So what is 57? 57 is fx4 only. So you can see it is fx4, it is x3, x4, it is fx2, x3, x4, this is fx1, x2, x3, x4, this is fx1, x2, x0, x1, x2, x3, x4. So these are the entries. Now, if I am writing some statement here, so you have to answer it. If we have x1, x2, x3, 3 arguments are here. So this is second order. So you have to one less than that. How many arguments are there? One less than that. And entry can be computed by 1 plus minimum. Minimum is 1, so 1 plus 1, 2. So I'm just repeating this. Suppose I have one entry here, f x7, x8, x9, x10, x11. So this is equal to how many arguments are there? I'm just counting 1, 2, 3, 4, 5. So this is the fourth order DD, fourth DD. Fourth DD. And entry number can be computed by, this is x7, so 8th entry. 8th entry. eighth entry in the fourth order. Eighth entry in the fourth order is the value or is the interpretation of this. So this will exist in the fourth table, in the fourth order divided difference, because 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So we have 5 arguments, so 4 TD. If we have 6 arguments here, the 5th TD, and so on. So I'm concluding the divided differences. The divided differences can be explained by how many elements there are in the argument. One less than that, the order number or the divided difference order column number can be obtained. And these divided differences are independent of order. Independent of order means this can be write down as fx4, x3. Both have the same answer. x3, x4 and x4, x3 both have the same answer. Why? Reason is we can write down this as fx4 minus fx3 divided by x4 minus x3. If I write down fx3 first and fx4 later, and if I write down x3 first and x4 later, the minus sign will be here and the minus sign will be here, and both minus sign will be cancelled out. So we can say x4, x3 and x3, x4 both are similar, because we can start by x4 or we can start by fx3. So divided differences are independent of the sequence of the arguments in the bracket. This is same as fx1, x0, x2, x3, x4. The both things are same. And it is same as if I started x4, x3, x2, x1, x2. Both are same. Because by changing the sequence of these arguments, the answer will not be changed. The answer remains same. So this is the divided difference table. Fx not expansion. We use the term expansion of DD, divided differences. How can we expand fx not x1? The formula is fx1 minus fx naught divided by x1 minus x naught. If I am expanding fx2, x3, x4, so this is equal to fx3, x4 minus fx2, x3 divided by x4 minus x2. This can be further subdivided by x4 minus x2 in the bracket. fx3, x4 can be represented by fx4 minus fx3 divided by x4 minus x3 minus, this is fx3 minus fx2 divided by x3 minus x2 and a square bracket there. This can be further summarized as fx4 minus fx3 and fx4 minus fx3. We can write down it as y4 minus y3, y4 minus y3, and x4 minus x3. If I take LCM, instead of writing in this pattern, I am just writing it by fx by taking LCM. So by LCM we have x3 minus x2 times fx4 minus I think is not correct. This multiply by this and x3 minus x2 multiply by. I'm just taking a call. Please wait for a minute. And that correction is this is
आपने क्यों हिलाया यार?
this is bifurcated as
इधर आ।
fx4 divided by, instead of taking LCM, I am breaking it, minus x3 minus fx3 divided by x4 minus x3. This is plus, not plus, this will be minus fx3 divided by x3 minus x2 plus fx2 divided by x3 minus x2. Now this can be multiplied by here fx4 divided by, because this is multiplied by this, x4 minus x2 and x4 minus x3 minus fx3 divided by x4 minus x2 and x4 minus x3. Then we have minus sign, fx3 divided by x3 minus x2 and x4 minus x2. And we have a plus sign here, fx2 divided by x3 minus x2 and x4 minus x2. Now we can take fx3 as common. We can take fx3 as common. Fx3 will be taken as common out of these two terms, middle terms. So this can be written as fx3 and x4 minus x2 is common, x3 minus x4 minus x3, x3 minus x2. So if I take LCM of these two terms, so this will be equal to what? This will be equal to x4 minus x2. This will be write down one time because it has two times. Then x4 minus x3 and x3 minus x2. Plus this term is as it is and this term is as it is. Now in numerator, x3 minus x2 should be here and x4 minus x3 will be here. Because we have a negative sign in between, so this is negative and this will be positive. Now what we can see here, x4 minus x2, x3 minus x3 plus x3. I think there is an error of a negative sign. If I take minus sign as common, then this will be plus. If this is plus, then this will be minus. And if it is minus, then x3 will be cancelled out. So what we have here, x4 minus x2 we will have here. And x4 minus x2 in numerator, and we have x4 minus x2 in denominator, so that will be cancelled out with this one. So what is remaining? So I'm just writing the remaining terms here and finalize this. The remaining term is the remaining term is this is equal to first term fx4 divided by x4 minus x2 x4 minus x3. Then we have a negative sign here. So we have fx3 fx3 divided by x4 minus x3 instead of x4 minus x3, I'm writing it as x3 minus x4. x3 minus x4. And in the next bracket, we have x3 minus x2. x3 minus x2. And we have a negative sign here. That negative sign will becomes positive. So how this sign becomes positive? Because I take one negative sign common here. That is x3 minus x4. So negative sign is taken as common, that negative, and that negative becomes now positive. Now the last term will be what? fx2 divided by, this will be write down as x2 minus x3 and x2 minus x4. Now this is the final term. What we have on the left side, we have fx2, x3, x4, fx2, x3, x4. This can be written as fx2 divided by x2 minus x3, x2 minus x4, fx3 divided by x3 minus x4, x3 minus x2, and fx4 divided by x4 minus x2, x4 minus x3. So these are the different expansions of divided differences. Now you can ask